Polluted water kills up to 14,000 people per day. Some claim it is even the #1 cause of death worldwide. There are two types of pollution: point source pollution and non-point source pollution. Point source pollution comes from a single source, usually from a pipe, municipal water treatment plants, factories, feedlots, or sewages. An example of point source pollution is the Kansas River, where wastewater from sewages and feedlots enters. Here is the Grand Calumet River in Chicago. Mercury, cadmium, chromium, and lead from industrial factories enter the river. The Tiber River in Rome suffers from sewage waste, along with Mapatu Bay in Africa. This is the Yellow River in China. Chemical factories have poured waste directly into the water, which allows the red color to form. Non-point source solution includes melted rain or snow moving across the ground, picking up pollutants as it goes. Eventually, the runoff will enter a large waterway such as a river or a lake. The Ohio River is 981 miles long and gives water to nearly 3 million people. Agriculture/urban runoff and metals from old mines pollutes the river. Much of the water does not meet the water standard quality. Due to the pesticides contaminating High Lake, Alaska, there has grown to be too much nitrogen within the lake. This is the Citarum River in Indonesia. It is the most polluted river in the world. Oil comes from oil spills, such as the BP oil spill in the Gulf of Mexico in 2010. 200 million gallons of water entered the waterway and killed many of aquatic life and birds that could not swim or fly with the oil. Fecal coliform is a bacteria, and it is the most common microbiological contaminant of water. It comes from sewage, runoff from agriculture, and animal waste. The impact on the environment of fecal coliform is the health risk with bacteria and diseases that it causes, such as typhoid fever and hepatitis A. And when you see fecal coliform in the water, it indicates fecal material in the water. Another contaminant of water is phosphorus, which comes from fertilizer in the form of runoff. The impact on the environment is that it causes the algae to grow too fast, which is called an algae bloom. This causes the food and water quality to decrease, and the dissolved oxygen also decreases. With the less dissolved oxygen, sickness and death fill the fish population. Bacteria also grows within the algae, which is a threat to the health of people. Removal of trees, bare patches in fields, and pavement of roads causes dirt to become a pollutant in water, as runoff carries dirt to the water. It impacts the environment as it clogs the gills of fish, which causes many of them to die, and also the lack of photosynthesis for plants because they cannot have sunlight with the foggy water. Turbidity measures the cloudiness and clarity of the water. A lower turbidity means it's more clear, while a higher is darker and more foggy. It is measured in Formycin turbidity units, or FTU, and it measures how much material suspended in water decreases the passage of light through the particle This is how we measure how much dirt is in the water. Bioassay uses living organisms to see the concentration of a substance in a waterway. The animals are able to detect whether or not the pollutant is in the water. This is how you can measure oil. Specifically in the Gulf of Mexico oil incident, mysid shrimp were used to determine the toxicity of oil and other drilling fluids that were let into the water. Also, Skeletoma algae were also used to determine the toxicity of drilling fluids in the seawater. This method could also be used to measure the phosphorus within a water environment. Fecal coliform in the water indicates a contamination with pathogens and a failed water treatment, and it enters the water through humans and animals' waste. The problems fecal coliform causes is that it reduces oxygen levels as aerobic deposition occurs of fecal coliform, and this can kill bacteria needed in the ecosystem. Dissolved oxygen is the measurement of O2 gas that is in an aqueous solution. Diffusion, aeration, and photosynthesis cause oxygen to enter the water. Oxygen shouldn't be above 110% in the water. Above that percentage causes problems and death within the population of fish and plant life in the water. O2 can be below 5.0 mg per liter. Biological oxygen demand is the amount of dissolved oxygen that aerobic biological organisms in water must have to break down organic material in a given water, temperature, and time period. One type of water treatment is sediment filtration. First, coagulation occurs, which removes the dirt and particles. Chemicals are added to the water, and the dirt particles become heavy and sink. Next, sedimentation occurs, and the particles sink, and the water clears. The water then is filtered, and water goes through filters to remove even more particles. Next, the water is disinfected, usually with a small amount of chlorine to kill the bacteria. Another type of freshwater treatment is distillation, which uses heat to evaporate the water while other things are left behind. Steam is condensed into a liquid and cools. The 3 ways to decrease water pollution includes not pouring any pills down the sink, not using any fertilizers, and providing education programs about water waste. This will help people learn what they can put down the sink and not put down the sink, and understand where wastewater ends up. The first type of water treatment is primary treatment. The first step of this is screening, which removes large objects in the water. The next is it goes to the comminutor, which gets rid of the larger chunks and shreds them into smaller pieces or chunks. In sedimentation, the matter sinks to the bottom and large objects are removed. In the last process, biochemical oxygen demand the oxygen needed for microbes in the water to digest the waste. Another type of wastewater treatment is secondary treatment. Aeration occurs either through air diffusion aerators or waterfall aeration. This degrades the pollutants as the water comes into direct contact with air. A secondary clarator causes sedimentation to occur again. The last step is disinfection, which removes pathogens. The water will then be stored. One law regulating water pollution is the Clean Water Act. It was created in 1948 and was originally the Federal Water Pollution Control. It regulates the discharge of pollutants and manages water standards. Another law is the Safe Drinking Water Act of 1974. It controls the standards for drinking water quality, which protects the nation's overall health. There are a few inventions that help to unpollute the water. One of them is the Life Straw, which is only $30 and directly removes bacteria as it enters firstly through a textile filter, and then a polyester filter, and then through a layer of beads mixed with iodine. So it uncontaminates it so it's drinkable and helps countries in poverty have access to clean water. It was invented by the Swiss company Vestergaard. Another inexpensive water treatment invention is the solar ball. It was invented by Jonathan Liao and uses a system of evaporation to purify the water. With 40% of the lakes and rivers polluted, we, as a worldwide community, need to find a solution to stop the pollution.